Hello, everyone. Today we're going to be talking about the Blackwell Tornado of 1955. This tornado was famously known for the blue or orange glow that it emitted during the nighttime. It was also known for its F5 rating, which took the lives of 17 to 20 people during that night. It was a part of an outbreak that spanned from May 25th to May 26th that year. Easily took the cake for being the strongest outbreak of that year. Eyewitness accounts report an orange slash blue luminescence glow being emitted by the tornado. Usually, if you want to see a tornado at nighttime, you have to wait for lightning or a transformer exploding, something like that. Usually, tornadoes don't start glowing um, just out of nowhere. So there has to be some sort of cause to this, and there's hasn't been solved yet. It's still a mystery to this day. But I'm going to share my opinion on this. Why I think this tornado may have been glowing. But first, let's look at an eyewitness account so you can kind of get in your head how this tornado may have looked like. All right, so let's look at this account according to Montgomery Lee Hunter, who was north of Blackwell during the tornado. The funnel from the cloud to ground was lit up. It was a steady, deep blue light, very bright. It had an orange-colored fire in the center from the cloud to ground. As it came along my field, it took a swath about 100 yards wide. As it swung from left to right, it looked like a giant neon tube in the air, or a flagman at a railroad crossing. As it swung along the ground level, the orange fire or electricity would gush out from the bottom of the funnel, and the updraft would take it up in the air and causing a terrific light, and then it was gone. As it swung to the other side, the orange fire would flare up and do the same. So if we were to imagine this in our heads, he said a steady deep blue light. So just imagine like a big neon blue tube. And then he also said an orange colored fire that was gushing out from the kind of center to the bottom of the tornado. He also said that this orange fire slash electricity was gushing out from the bottom of the tornado. And if we were to look at a tornado, like a photogenic, easy to dissect tornado, we have our condensation funnel up here, our wall cloud. That's not important to what we're looking at. We're looking at the very bottom, and that is that debris cloud that's visible. Now, I could see a debris cloud being described as, debris gushing out from the bottom of the tornado. Now, my theory is this was quartz. Quartz, when you strike it together, it creates an orange glow or a blue glow, depending on how pure your quartz is and if there's any impurities in it. Uh, in assuming there's a ton of quartz in the ground, it gets picked up by the tornado. In the rotation of the tornado, it's all going to be crashing into each other, chipping and rubbing against each other, and that's going to create that glow. Now, for the blue glow, the blue glow comes just from quartz itself. The orange glow comes from the sodium impurities in the quartz, which sodium glows a very bright orange. So that'll easily overtake that kind of faint blue glow that pure quartz emits. So what I'm thinking is the quartz got so polished by rubbing up against each other and so chipped that eventually it became so clean of impurities that you could really kind of visualize the blue light a lot better. It was also pitch black. There was probably a lot less light pollution back then, especially in Blackwell, Oklahoma, and it probably would have been easier to see that blue glow. All right, do you want to know why these pieces of quartz can start glowing? Well, that's called triboluminescence. And triboluminescence is the emission of light caused by mechanical energy, such as rubbing, scratching, and chipping, uh, which applied to a solid material. And basically, it works when stress breaks atomic bonds, creating an electric charge imbalance that causes electrons to jump across the gap. You have a negatively charged side and a positively charged side. The electrons jump in between the gap, being attracted to both sides, and in between them is a pocket for air. The electrons will hit the air molecules, which will ionize them, and usually these air molecules are going to be nitrogen. Nitrogen glows a blue hue, but the problem is that quartz, it's not perfect. It has other contaminants on it, such as sodium. Sodium glows a deep orange, and whenever it gets caught in the mix of this, it'll project that orange glow, and it'll overpower that blue glow. You have to get a really pure piece of quartz to get that blue glow. But basically, how you even get the glow in the first place is in the process of the electrons jumping. They jump from this low energy level to a high energy level, back to a low energy level. Now, when you get from here to here, you gotta get rid of the energy somehow. So that energy is gonna be expended using photons or heat, and that's how you're gonna get that glow that you're seeing. Is That's the electrons expending their excess energy. So I hope you learned a lot from this video, and I want to touch on one last thing, and that's the theory of the glass factory causing the glow. Now I could see this theory. You have molten glass, like fire, and everything is hot in there. Um, but I wouldn't see molten glass causing a blue luminescent glow that's consistent as said in the eyewitness account. I also wouldn't see it being as a consistent orange glow because, uh, again, a tornado is mainly water vapor, and it also can be rain wrapped. So this glass would be probably cool pretty fast and lose its glow and not be consistent at all. Thing is, as quartz, if you're just constantly rubbing against each other over and over again, rotating a tornado, it's going to be consistent. It's going to be constant because it's not it's not kept at a certain temperature to work. It just doesn't. So that's my theory on it. If you have any other theories, and put them in the comments. If you want to add on to this one, please do. I hope you enjoyed this video and have a good day.